بسم الله الرحمن الرحيم. Come to the fourth part of the inverse matrix topic. The inverse matrix, as we mentioned before, it is a matrix when we multiply it by the matrix A times B equal to B times A equal to the identity. In this case, we say that B is inverse matrix of A. Where A is square matrix n by n. And to find the inverse, we said that the inverse equal to 1 over the determinant of A multiplied by the adjoint matrix of A. Or another way to find the inverse, we can write the A times the identity matrix and convert it to the matrix or to the form I inverse. This is how to find the inverse matrix. I mentioned this before in the last part. Now for today, we are going to give a new idea or definition for the matrix. Say that a non-singular matrix A said to be orthogonal if A inverse equal to A transpose. Given non-singular matrix A, then we say that it is orthogonal if A inverse equal to A transpose. Let's take some examples. Verify that the given matrix is orthogonal. First one, A is given by sine theta, cosine theta minus cosine and sine theta. So I need to check whether this matrix is orthogonal or not, or we need to verify that this matrix A is orthogonal. It means that we need to show that the inverse of the matrix A is equal to A transpose. So we need to find the inverse of this matrix, or just find the A transpose and multiply it by A and check whether that we get the identity matrix or not. So either we will find the inverse of this one using the adjoint form, or multiply the A by the A transpose. So we have two ways. First method, multiply the A by A transpose and check we're going to get the identity or not. Or second one, we know that the A inverse equal to 1 over the determinant of A multiplied by the adjoint of A. See the second one. Determinant of A, which is equal to sine theta cosine theta minus cosine theta sine theta. This is equal to sine times sine equal to sine square minus cosine square, which is equal to 1. So the inverse is equal to 1 over 1 multiplied by the adjoint. Adjoint means we need to switch between the main diagonal, that will be sine and sine, so there's no change. And multiply the other diagonal with negative sign. This will be cosine theta, and this will be minus cosine theta. But this is the transpose of the matrix. We can check this more. So A is orthogonal. It's very clear that this is orthogonal. Or let's just find A transpose multiplied by A. That is sine theta minus cosine theta. Cosine theta sine. This is the transpose multiplied by A, which is sine theta cosine theta, and minus cosine theta sine theta, which is equal to sine times sine will give me sine square. This out. Minus cosine with minus cosine will be plus cosine square. Now sine with cosine will be sine theta cosine theta minus cosine sine. Go for the second row. Cosine times sine will give me cosine theta sine theta minus sine theta cosine theta. Go for the second column. I will have cosine square plus sine square, which is equal to 1, 0, 0, 1. But this is not enough because this is only one side of the equation. We said that for the inverse, A times B equal B times A to satisfy the identity. Because we know that for the product of matrices or multiplication of matrices, they are not commutative. A times B is not equal to B times A. So we check only one side. I have to check the second part, which is A times A transpose. Change the order. That will be sine theta cosine theta minus cosine theta by the transpose of A, that is sine theta minus cosine theta cosine theta and sine theta. Check this one. We'll have sine with sine, sine square, cosine with cosine is cosine square, and we will get 1. Now sine times minus cosine and cosine with sine, this will give me 0, 0, 1. This will be very easy to check this one, which is the identity. It means A transpose equal to A transpose A equal to I. It will give me that A transpose equal is the inverse of the matrix A. It means A is orthogonal. Take another one. Number 2. A is equal to 1 over third root of 3. Another 1 over third root of 3 and 1 over third root of 3. 0, 1 over square root of 2 minus 1 over square root of 2, and we have minus 2 over square root of 6, 1 over square root of 6, and 1 over square root of 6. We need to check whether this matrix is orthogonal or not. Let's find the transpose for this one. Be 1 over third root of 3, then 0 minus 2 square root of 6. Second one is 1 over third root of 3, 1 over square root of 2, and 1 over square root of 6. Just change the rows into columns. Third one is 1 over square root of 3 minus 1 over square root of 2 and 1 over square root of 6. Now all what I need, we need to find A transpose times A and also A times A transpose. Let's find A transpose times A first. Over multiplied by A, that is 1 over third root of 3 0, 1 over square root of 2 minus 1 over square root of 2 and minus 2 square root of 6, 1 over square root of 6 and 1 over. Let's find the product of these two matrices. Row into the column. 1 over 3 times 1 over third root of 3 will give me 1 over 3 plus 1 over 3 plus 1 over 3. This is the first element. Now go for the second column. I will have 0 plus 1 over square root of 6. Square root of 3 multiplied by square root of 2 is 1 over square root of 6. This one with the minus will be minus 1 over square root of 6. This will be the second element in the first row. Go for the third column. I will have minus 2 over square root of 18 plus 1 over square root of 18 plus 1 over square root of 18. Now let's do it for the second row. This one. We'll have 0 plus 1 over 2 minus 1 over or plus 1 over 2. This plus minus with minus is plus. Sorry, I need to multiply by the first column first. It will be plus 1 over square root of 6. This one with this one. Minus 1 over square root of 6. Now let's do it for the second column. It will be 0 plus 1 over 2 plus 1 over 2. Go for the third column. We have 0 plus 1 over square root of 12 minus 1 over square root of 12. Multiply the third row by the first column. I will have minus 2 over square root of 18 plus 1 over square root of 18 plus 1 over square root of 18. For the second column, it will be 0 plus 1 over square root of 12 minus 1 over square root of 12. Third column, I will have 4 over 6 plus 1 over 6 plus 1 over 6. This will give me 1, 0, 0, 0, 1, 0, 0, 0, 1. Which is equal to the identity. By the same way, let's find A times A transpose. Let's apply the same process, but just reverse the order of the matrices. That will be it is very easy to check that you will get the identity 1 0 0 0 1 0 0 0 1. It's multiplied and you will find that it's equal to this one. So we will have A transpose equal, or times A equal to A times A transpose equal to the identity, which means the A transpose equal to the inverse. Because this is the definition of the inverse. So the given matrix A is orthogonal. It's straightforward to check whether the given is orthogonal or not. Just find the A times A transpose and A transpose A. If both of them gave me the identity, then the given matrix is orthogonal. Take one more example for the inverse matrix. Find a value of x such that the matrix A given by 4 minus 3x minus 4 is its own inverse. Means that A equal to A inverse. So I need to find the value of x so that A equal or it is its own inverse. So all what I need to find A times A. This must be equal to the identity. This is the meaning of its own inverse. If you multiply the matrix A by itself, I will get the identity. So we have 4 minus 3x minus 4 multiplied by 4 minus 3x minus 4, which is equal to 16 minus 3x. Row is column. And minus 12 plus 12. The second one, x times 4 is 4. X minus 4x, that will be 0. And x times minus 3 is minus 3x plus 16. Which is equal to 16 minus 3x, 0, 0 minus 3x plus 16. And this is equal to the identity. And as we defined before, two matrices are equal if the same entries in the same position are equal. So from this equality, we'll say that 16 minus 3x equal to 1. Which means this is just a linear equation. 3x equal to 15. 3x equal to 15 or x equal to 5. So x is equal to 5. We can check this one. Then A is equal to 4 minus 3, 5, and minus 4. A times A is equal to 4 minus 3. This is just to check. Is equal to 16 minus 15. Second one would be, if one is 0, and this is 20 minus 20 also 0. What is it? Let's say and minus 15 plus 16, which is equal to the identity. So the value of x equal to 5, so that the given matrix A is its own inverse. So this is the idea of finding the inverse and how to apply some concept for the inverse matrix. So we are done from this topic. Find the inverse, define the orthogonal matrices, and apply some concepts.